Okay, so here's the first question of my Pre-calc 12 midterm project, and we're doing unit for logs. And I'm Julia Jankovich, if I didn't already say that. Okay, so the first thing we want to do is, for question 1, is read it. So, at what rate of investment would an investment have to be paid for an initial $1,000 to grow to $20,000 in 12 years if the investment is compounded quarterly? So, first you have to look at what the equation is asking. So, it's asking for what the final amount will be. And so, we'll have to write an equation for this. So, the equation for this type of question is A equals P1 plus R over N to the NT. And so A equals the final amount, P equals initial, N equals the time compounded quarterly, T equals time, and R equals the rate of interest. So for our final amount, it's asking if our initial $1,000 will grow to $20,000. So our final amount is $20,000. Our initial amount is $1,000. Our time compounded is quarterly, so it will be 4. Our time is 12 years, so our T will be 12, and our rate of interest is what we're trying to find. So the first thing that you do is we're going to sub in all of our values that we have into this equation. So first, it's going to be 20,000 equals 1,001 plus R over 4 to the 4 times 12. Just like this. So the first thing that we want to do is we want to bring the 1,000 out of this side and bring it over to this side. So we have to divide both sides by 1,000. This here simplifies to 20, and these two cancel out, so then we're left with 1 plus R over 4 to the power of, we'll multiply this together to the power of 48. So then the next thing that we want to do is that we have to use logs in order to cancel or bring down the 48 in order to figure out the rest of the equation. So what we're going to do is we're going to log both sides. So the side will come to log 20, which equals log 1 plus R over 4 to the power of 48. And what logging does is we can bring the exponent down in front of the log. So we'll do that now. So log 20 equals 48 log 1 plus R over 4. So now that we have this, what we want to do is we want to bring the 48 over to this side. So divided by 48. Divide this side by 48. So now what we do is we have to evaluate this side because these two will cancel out. So we'll do that now. So log 20 divided by 48 equals 0.0271, we'll call it, which is equal to log 1 plus R over 4. So to make these two equivalent to each other, so we can bring out this log, we can bring this value, or we can do 10 to the power of this. So 10 to the power of 0.0271. And of course, when we do this equation in our calculator, we'll use the unrounded version to get a more accurate number. Equals log, no log, because that's what we're doing to make it equivalent to it. So this valued is 1.064, and we'll round it to 4 for now, equals 1 plus r over 4. So now, as we're trying to isolate for 4, we have to minus 1 from this side and minus 1 from this side. So minus 1 equals 0.0644 equals r divided by 4. So one last step to get r alone is we have to times both sides by 4 times 4, and we get 0.2576 equals r. We're not quite done because this is the value of r, but it's asking for the rate, and so we have to times it by 100. And so the rate is 25.76% equals r. Okay, so now for question 2 here, it's use the laws of logarithms to simplify and evaluate log base 4 to the square root of 12 plus log base 4 to the square root of 9 minus log base 4 to the square root of 27. So what we can do here is, according to the laws of logarithms, when it has the same base, when a log has the same base as what it's being added to or subtracted from, you can multiply when it's added and divide when it's minus. So what we'll do here is we'll show that this equals log base 4. Now there's an addition sign between the log base 4 to the square root 12 and the log base 4 to the square root 9. So that means that we multiply these two values. Square root 12 times the square root 9. And we'll just put back brackets around that. And then the next step is we look at these two, and we see that the log base 4 to the square root of 9 minus log base 4 to the square root of 27 are subtracted from each other. So that means that this value will be on the bottom of the division sign. So we'll bring the square root 27 underneath the other two equations. So when we do this math here, it'll be log to the 4, and then we'll see it is square root 12 times square root 9, see what that is, divided by square root 27, which equals 2. So now we're left with log to the base 4, 2. And then from there, what we can do, instead of looking at our calculator, if we want to do this calculator free, we can look and see, or I guess not totally calculator free because we'll have to use calculator in the next step, but you could either calculate this in your calculator by going to your math button, going all the way down, and clicking the A, log base, bracket, and then you could just fill in the values here. But what I like to do is I like to split them apart and go log 2 divided by log 4. And then so you just bring the base on the bottom and then what this is on the top. And then you evaluate this. So log 2, this is when you use the calculator, equals 0.30103, let's call it, divided by log 4. And log 4 is 0.60206. So these two divided by each other is divided by 0.5, which equals 1/2. So your answer is the simplified version of the logs is 1/2, which is nice, easy, and simple. Okay, and so for the last question, question 3, we have nickel 65 has a half-life of 2.5 hours. What fraction of the sample will remain after 10 hours? How long will it take for the mass to decay to 1/1024 of its original mass? So this is two questions within one. So we'll start with the what fraction of the sample will remain after 10 hours. So the first thing that we have to do is we have to look at the equation for half-life. So the nitrogen left equals 1/2 of the time divided by the half-life. So what we'll just do for the first part of the question, it's super simple, is we have to sub the values in. So n equals the half-life. So t, the time, is after 10 hours. So 10 divided by, and then the half-life is 2.5. So then we simply just evaluate that in our calculators. So 1/2 to the 10 divided by 2.5 equals 0.0625, which simplifies to 1/16. So this is how the fraction of how much will remain after 10 hours. And then we'll get to the second half of the question, which is how long will it take for the sample to decay to 1/1024 of its original mass. And then, so to do this, we have to equate the two. And so 1/1024 equals 1/2 t over 2.5. And it's t because it's not 10 hours anymore. We're trying to find what the time is. So what we have to do is we have to look at this, and then we can see that we want the two bases to be equivalent to each other. So just off the top of my head, I know that 2 to the power of 10 is equivalent to this. So we'll just double check that here. Yeah, okay, so 2 to the power of 10 is 1024. So we can make this and change the base to 1/2 10, which equals 1/2 t divided by 2.5. And then whenever we have two equivalent bases that equal the same, we can just cancel them out and use their exponents. So 10 equals t divided by 2.5. From here, we times this side by 2.5 to isolate the t, and that means we also have to do it to this side. So 10 times 2.5 is 25. So 25 equals t. So now we know that after 25 hours, it'll be 1/1024 of its original mass. So we'll just do that, and ta-da!